Hey y'all, so today we are going to be talking about creating and understanding graphs using TOX. So what is TOX? TOX is an acronym that helps us identify the components of graphs and develop a deeper understanding of what those graphs are saying to us. And so each letter stands for something different with our graphs. So T for title, A axis, L labels, K key, and S for says. So let's move into our title. So our title of a graph is going to name and identify the graph. And so this is just going to give a reader a very brief understanding of what your data is going to represent. And so this can be a few words or a little sentence, but it should include both variables of what you're testing. And what I mean by that is when I read the title, I should understand what is going to be my y and my x axis, but we'll get to that later. So let's look at some examples. Our first example is right here on our left. And so we know that our title is going to be at the top. And so right here, our favorite sports, that's the title. And this is telling me immediately that this is probably going to be about sports. And if we looked at it at our data, we can see that this is about sports. So this was a good title for this graph. And then over here on our second example, our title is How Long Animals Can Hold Their Breath. And so I immediately know that this is probably going to be about time, because it says how long, and then also animals. And so it helps me identify the variables that were being tested. And so once we can identify the title, I said that we could move to the axis, right? We could dig a little bit deeper into what our data is trying to say. And so it's a lot easier to talk about the axis with a picture. So I'll just run through this really quick as a little refresher. The independent variable will go on the x-axis. Your dependent variable will go on the y-axis, and it's always important to choose an appropriate scale. You want to make sure that you look at all your data points at this point and identify your lowest value, your minimum value, and then your highest value, which is your maximum value. And that's going to help you set up your x and y axis. That way all of your data is included, but you also don't want to have too much empty space, right? So your data has to cover at least 50% of the graph for it to be considered an effective graph. Otherwise, there's just too much blank space, and it would be a little confusing to read. So here is how we can explain axis. Our title is Temperatures at Family Reunion, and so time is on the x-axis. Time is always going to be our independent variable. And so this person has chosen to use 1 hour increments to denote each unit forward on the x-axis. And so you can see clearly right here, 8 to 9, 9 to 10, and it even gives the units of AM and PM to help us understand that data even further. So I can understand that this is the afternoon and then this is the morning. And then on our y-axis, we have temperature, and we've chosen the units of Fahrenheit, and the data goes all the way from 65, or it looks like it goes to, right under 70 degrees Fahrenheit and right above, 88 degrees Fahrenheit. And so that is why they've chosen the scale of 65 degrees Fahrenheit to 90 degrees Fahrenheit, because it gives just the perfect window. See right here, just the perfect window to show our data. But it doesn't give too much space on the top and too much space on the bottom. This was the perfect scale for our axes. And so our next letter is actually going to go hand in hand with our axes, because it is our labels. And so both of our axes are labels. And then here's just another refresher again about the independent variable being on the x-axis and the dependent variable on the y-axis, that you might get a little confused once you set up your units. You may not understand how to label them. Just look at what you're trying to say, and that will help create your labels. So let's look at those charts we saw at the beginning. We already identified that the title was our favorite sports, and so they've identified the axis labels down here as sports, and then number of students. And so if I wanted to look at the different types of sports, I would come along the x-axis and I could say, oh, here's soccer or basketball. And then on my y-axis, this is going to tell me the amount of students that liked that sport or that was their favorite sport. And then over here on this example right here, my x-axis label is number of minutes, And then our y-axis label is types of animals. And so I can come to my y-axis and say, oh, this is the whale. And then I can move right here and understand that it held its breath for 19 minutes. It helps me narrow down my data even further. And so K is for key. And so this is not always used on graphs. It's particularly helpful for our example here, like a double line graph or a double bar graph. It's when we have different data sets that we're trying to identify under the same parameters, same testing parameters. So this is what we saw before, the temperatures at the family reunion. If we didn't have that key right there, so just imagine that this is completely missing, we would have no idea what these lines right here represented. We could make guesses as to what they represented, but there would be no real way for us to understand what this red line represented and what this blue line represents. And so if we add a key, that helps us understand our data a little bit further. We now see that that red line represents the outdoor temperature and that the blue line represents the indoor temperature. And so there's a couple different ways that we can use keys too. There's also keys used in a pie chart like this. And so our title is a pie chart showing a key. And you can see that each category is sectioned off into colors, and each color is indicated over here in our legend. And so I can see that this red piece right here belongs to John, that the blue piece belongs to Pete, this yellow right here is Gary's spy. It just helps us narrow down our data even further. And so once we get an understanding of what our data is kind of trying to say to us, we can start to make decisions about that data. So what is the data saying to you at that point? Once you have an understanding of the names and the variables, you can start to make actual decisions and apply that data to your life. And so let's look at some examples. Here's our graph from earlier. We already identified T, A, L, and K. But what is this graph actually saying? And so this gets a little tricky for people because there are more than one right answer. There's more than one right answer for what this graph is saying to you. Different people can draw different conclusions from the same data that you can. And so some possible examples that you could choose for this, you could say that that more boys liked basketball than girls did. Significantly more. Right here we had 5 boys compared to 1 girl that liked basketball. But then in comparison over here, we've got a lot more girls that like soccer than boys do. Or you could say that softball had the same number of boys and girls that like it. And so how do we use this to make decisions in our life? Well, maybe we took a poll in our class to see which games we're going to play at our next field day. And so maybe we would choose basketball and soccer as our activities as comparison. Maybe we wouldn't choose volleyball because that wouldn't make as many kids happy. And then one more example of that is here's our family reunion temperatures again. We already know what the title, the axis, the labels, and the key say, but what does this overall mean to us? And so from here, I can draw some conclusions that the outdoor temperatures, it was extremely more hot outside than it was inside. It was very cool inside throughout the day. It never left the 70s, which sounds really nice. And so you can make decisions this way. So if you're going to have a family reunion, maybe it's a good time to be at the lake between the hours of 11 and 3 because it's going to be very hot. You're going to want to be in the water. Also probably a good time to use sunscreen. But if you don't like being in the heat, maybe you would want to stay indoors during that time. And so as we use talks, we can just develop a deeper understanding of what our graphs are trying to say to us. And so thank y'all. Y'all have a good one. Bye.